Stationary points. A stationary point on a curve occurs where the first derivative, f dash of x or dy dx, is equal to 0. This means the tangent to the curve is horizontal, and we can see that on the points we have below, meaning that at these points the gradient is 0. There are three types of stationary points. There is a maximum turning point, which we can see here. The curve changes from increasing to decreasing. So the gradient is positive here, 0 here, and then negative. Minimum turning point. The curve changes from decreasing to increasing. So negative gradient, 0 gradient, positive gradient. And then we have the horizontal point of inflection. The curve flattens out but continues in the same direction. So with the one drawn, we have a positive, 0, positive, but they can just as easily be negative, 0, negative. Another consideration is the concavity of the curve. Concave up, nice and easy to remember, is U-shaped. Concave down is in the other direction. When we have a point of inflection, the curve changes from being concave down, if you follow the line of the curve, to being concave up, or the other way around. It changes from being concave up to concave down. Stationary points can be located, or at least the x-coordinate can, by solving f dash x is equal to 0. We can investigate the nature of stationary points, i.e. determine whether we have a maximum, a minimum, or a horizontal point of inflection by either applying a sign test or applying the second derivative test. A sign test would appear as below, the stationary point being at x equals a. So for a local minimum, and we can see the shape here is a minimum, the turning point itself, or the stationary point itself, is at a, so the gradient there is 0, so f dash x is equal to 0. We take a point to the left, and in this case it's negative there. Point to the right, in this case the gradient is positive, and so we get negative, 0, positive, so we have a minimum. The important thing is that this point that we choose to the left and this point that we choose to the right must not go past another stationary point. So it's to the left, to the right, but not past another stationary point. Then we have the local maximum. If it's located at A, the gradient there is 0. Take a point to the left, the gradient there is positive. Point to the right, the gradient there is negative. And so we end up with a local maximum. And we have the same sort of thing for the point of inflection. We've got the gradient here. And in this case, it's going negative, 0, negative. So like that, but you get the point of inflection. And in this case over here, it's going positive, 0, positive. And so we have a horizontal point of inflection. The second derivative test is as follows. F double dash of a, that's the second differential, is greater than 0, indicates a local minimum. That's because when the second derivative is positive, the curve is concave up, and so we must have a minimum. F double dash a is less than 0, so it's negative, indicates a local maximum. When the second derivative is negative, we have a concave down curve, so we would have a maximum. It's important to note, though, that f double dash a equals 0 tells you nothing, so when you get that situation, revert to a sign test. Note, the second derivative is always 0 at a point of inflection, but can also be 0 at a maximum or a minimum, which is why we should revert to the sign test. This is illustrated in the example below.